Thank you. So my name is Lars Bendix. I've been given the joyful task of trying to wake you up after lunch. And I'm going to talk about how to introduce software configuration management in a young Agile startup. If you want, you can take a picture of this slide, so you got my contact information. So I'm also administrating a network of people that are passionate about software configuration management. And in my spare time, I'm a university professor at Lund University in Sweden, where I teach a course in software configuration management. But let's move on. So if you're into software configuration management, you know that software configuration management activities, they have to be carried out on any type of project. If you don't have any software configuration management activities, chaos and anarchy will reign. Sometimes, even if you have software configuration management activities, there will be chaos and anarchy, but that is due to other causes. So software configuration management has to be present also in a young Agile startup. So let's try to see how we can convince these people that it's good and useful to have software configuration management. Before that, we have to realize that on most projects, the actual operational work of software configuration management are carried out mostly by people that have no software configuration management education. So they be told to do a task, they do the task, and they really don't have any much insight into what it is that they're doing. Basically, no tools in their software configuration management toolbox. They might be able to do a lot of different things in a good way, but no one took the effort to try to teach them some software configuration management tool. Since they don't know what are the concepts and principles behind, since they don't have any tools in their toolbox, then they're struggling. They might not do the operational task in the right way. They don't have any idea of why they're doing it. Sometimes they miss out on important things of software configuration management that you should do. And since they don't know why they're doing it, what is the task, what is the problem, what are the tools we could use, they don't know how they can adapt what they've been taught to do in a different context. So we need some strategic software configuration management. We need someone who can sort of design the software configuration management processes and that can also teach and educate these people who have to carry out the operational work. The purpose today is that the reason why I'm trying to introduce software configuration management in a young Agile startup is that this is just about the most lean and resource-poor and informal organization that you can think of. And my purpose is to show that even in that lightweight context, software configuration management has a place. Another advantage of taking a startup is that it covers everything, from programmers over testers to designers, project managers, and it covers everything from idea to product. So we cover everything wall to wall. Now the setup that I give my students on my course on software configuration management, they can choose some projects that they will have to work on during the course. And one of the projects is about introducing software configuration management in a young startup. And this is the setup that I give them. 4 friends just about to graduate. They're living 24/7 in a borrowed garage. They didn't follow my course, so they know absolutely nothing about software configuration management. So they will hire you as the expert who will try to teach them something. Given that they don't have any resources, they can't pay you a salary. So the only thing that they can do is that they give you 10% of the company. So it's also in your interest to make this company survive and be successful. There's a lot of uncertainty and changing goals. They have many ideas that they want to try out, and now they're just about ready to get going. So let's see. Some of the things that we have to do to make this young Agile startup survive the first week, the first month. If we introduce software configuration management wall to wall, the way that it should be done, then they can do nothing but trying to digest all these new things in the first month. And they don't want to do that. So we should try to introduce software configuration management step by step. What is the most important thing to introduce first? What should we then do next? And so on, step by step. We should do it in a cost-effective way, not just because they don't have money to pay us, but they don't have money to pay a lot of expensive tools, and they don't have time and resources to spend on very elaborated processes, at least in the beginning. They just want to move on. It has to be carried out by these 4 guys in the startup, the developers, the operational part, and we, as the strategic SCM experts, we have sort of to design the overall processes and try to teach these people how they can do the operational work behind the processes. So basically, the 4 questions to software configuration management: what is it that they should introduce? Sort of at the conceptual level, what is the solution? Why are you doing this? Sort of, given that this is the solution, what is the problem that we're trying to solve? Something about when, a prioritized step-by-step introduction. And today I will not say very much about the how part, because that could be a whole course, and I could fill a day or 2 or 3 with that. So let's move on. When my students, they do the projects, this is usually what they say that is the first step. Git, branching, distributed development. And we use the project for the exam. And I tell the students, well, that's not my idea of where you should start if you have a young Agile startup that you want to introduce to the world of software configuration management. So why isn't it distributed development? Well, I told the students that they're working in a garage, 4 people. There are 4 corners in the garage, but I guess they can sort of communicate without any problems. So they're not distributed in, at least not now. Branching, well, let's try to start off simple. If we can get it going in a simple way, then maybe further ahead we can look at how they can do branching, if they really need to do branching. Git, I might not have been very clear in my problem description that these guys have not yet written a single line of code. They're still brainstorming on ideas. So maybe it's a little early to introduce them to Git. I also took this to my network of people passionate about software configuration management, and I asked them, what would be the first step? What would be the first thing that we should teach this young Agile startup? And they said things like tagging of source files, identification of configuration items, tools, registry of configuration items, collaboration tools, change control, stuff like that. To me, that seems probably a little bit of a wish list for the current situation that they're in their company. So they're already doing stuff, they already have some kind of configuration management in place, and this is probably what they would like as their next step in the company where they are. But it doesn't really mirror the ideas that I have of the first and most important thing to introduce to a young Agile startup. So then what? At the oral exam for my students, when we get to this point, they sort of say, well, if it isn't Git and branching, then What about Wayne Babbage? The 3 coordination problems of a team that Wayne Babbage identified. These students, they know that my superhero of software configuration management is Wayne Babbage. So if it isn't Git, then definitely it must be Wayne Babbage. Well, still, it's a little bit early. So they still haven't got to the coding phase. So it's not Wayne Babbage, not now, a little bit later on this. Then some, with a little nudging, they arrive at Daniels, the author of the book that we use for the traditional configuration management. And they arrive at probably the most formal and bureaucratic part of software configuration management, the traditional configuration management, defined by the standards, the configuration control, also known as change management. So right now they're middle of a process of revising the standard, and they have decided that instead of calling this activity for configuration control, they want to call it for change management, which is really a pain for me because I've got like 200 slides where it says configuration control, and now I have to change in 200 different places because there's the double maintenance problem that Wayne Babbage has identified. So why is configuration control or change management so vital for the survival of a young agile startup? Why is that the first thing that I want to tell them about? Well, what is it that a young agile startup has? Hopefully, they have 1 million ideas. What is it that they do not have? Well, we've already been through it. They couldn't pay me as the expert, so they gave me 10% of the company. So they don't have any time and resources, very little time and resources. When you have 1 million ideas, when you don't have a lot of time and resources, it becomes very important for you to prioritize, to focus on what is the most important thing right now. And we as configuration managers, we can help on that. We know of good ways of working when you have to handle 1 million ideas and prioritize them. What is that you should do? So at this point, when these 4 guys realized that maybe configuration control is important, we need to focus, we need to prioritize, they will be ready and motivated for listening when I talk about change requests, a CCB, and a change process. So how to document the changes, how to decide and prioritize on what changes we should do, and defining a process for how we handle these change requests before the CCB meeting and after the CCB meeting. A little bit on how we could do that. In my course, I tell my students that most things in software configuration management, the answer starts with "it depends on," especially when we go down into the implementation details. So how should we implement the change request on this young agile startup? Well, it doesn't have to be very formal. Yellow post-its. So if you got a right idea, you write on a yellow post-it and you put it on the whiteboard. If you got a greater idea and it doesn't fit into a yellow post-it, you take an index card or piece of paper that is slightly bigger and you put it up on the whiteboard again. The change process, well, we have to document what it is that we want to do. Is it a bug fix? Is it a new feature? And do we have some technical debt that we want to clean up, or whatever it is? We have to filter. Maybe you found a bug, he found the same bug, and he found the same bug. Now we got 3 post-its on the whiteboard saying that there is a bug here. We don't want to deal with that 3 times. So we should filter and try to put them together. We should analyze and estimate what is the impact of this, what is the cost. And finally, we need to decide, is it important to fix this bug? Is it valuable to implement this feature? When we have decided that, we have an implementation phase, and maybe we want to follow up on that also. How far have we come in the implementation phase? Or we want to ditch it, and sometimes it's just taking the yellow post-it and throwing it away. The CCB, the Change Control Board, for my students, it seems quite formal, but the purpose of a Change Control Board is that when it is provided with perfect information, then it makes perfect decisions of what it is that we should do and should not do. So basically, a CCB is a decision machine. If we put garbage in, we'll also get garbage out. A CCB on an Agile project, well, basically it's these 4 guys standing in front of the whiteboard discussing what is it that we should do, what is it that is important, what is it that we should plan in the next sprint. If you work in a more traditional company, if you develop software for control, software for nuclear power plants, you will probably do it in a slightly different way. But the concepts and principles are exact same. So you still need to document, filter, analyze, estimate, and decide. And we have sometimes discussions at the exam with my students. The standard says that there is a chairman for the CCB, and the chairman is the dictator, and the chairman makes the decision. And I say, okay, now we got these 4 guys in the startup. How will we make decisions? And they have a little problem, because sometimes during the exercises they have suggested that, well, we could vote about what we should. And I tell them that maybe we are in Sweden, maybe Sweden is a democracy, but I'm sorry, a CCB is not a democracy, it's a dictatorship. And then they have problems with this young Agile startup. And I say, well, at a certain point, you said that as who we could put in the role as a chairman of the CCB, and you said the owner of the company. I say, who is the owner of this Agile startup? And I say, well, they all 4 own it. And I say, yeah, okay, then as the first step, we put all 4 as the dictators, and they will have to fight it out. After a while, a month or so, you are usually the guy who has the contact with the investors. So you have a pretty good feeling of what it is that they want. So now, instead of having just 1 vote, when we put it to the voting, you'll have 2 or 3 votes. Or you'll be the marketing, and you'll have the contact with our users. So you know what they're interested in. So now you'll have more votes. And gradually we will find a way of doing this. The important thing is that we have to prioritize and make decisions. And to make decisions, we need sort of perfect input. Perfect, with the resources that we can spare. Tools, well, if we really want to have more sophisticated things like than the whiteboard, we can have tools like Jira, Trello, Kanban, planning game, backlog grooming. It sort of all belongs to change control, and then a CCB meeting is nothing but a planning game. And a backlog grooming, that's what's happening there. Now that they know what to work on, then what is the next step? Well, my friends of the passionate configuration managers, they have another long wish list, process for development after the CCB, now that we made a decision, Jira with Kanban in the middle of workflow, definition of done or definition of ready, where to put the source code, how to deliver, how to develop, traceability, stuff like that. It's not completely off, but I wanted something more precise. So the next step, now that we have taught them about change requests and CCBs and how to handle that, is actually configuration items and artifacts. To tell them the difference between artifacts and configuration items and why we should talk about configuration items. Everything that floats around in this Agile startup are artifacts. A certain part of these artifacts are important, and they become configuration items. And once they are configuration items, they come under the protecting wings of the configuration manager. And the configuration manager will take care that nothing bad happens to these configuration items. When we at the exam discuss what should become configuration items, sometimes my students say that, well, let's just turn all the artifacts into configuration items. And usually I tell them that if you go and ask your project manager about that, he'll say that's far too expensive. If something becomes a configuration item, it's true that it's under the protecting wings of the configuration manager, but it has a cost. And we don't want to pay the cost for all the artifacts. So these things that are really important, these things that must not get lost or randomly changed. If someone changes or removes the source code, we are fried, because we cannot produce the product that we have to use. So important things must not get lost. In the standards, generally what the definition of a configuration item is that it is everything that we need in order to be able to produce the end product that we have to deliver. Source code is usually very important. Test cases, requirements, documentation, stuff like that. These young guys have to make sure that once we have all our bright ideas up on the whiteboard, that the mother of the guy that has the garage doesn't decide that she wants to clean up the whiteboard to make a little bit of order in the mess that these guys have created. Then all our ideas go away. So they might be important and they might be considered configuration items. Libraries that we use to develop our brand new fantastic application. I don't understand why even some mature companies decide to use libraries that reside somewhere on the internet. What happens the day that this library is not there anymore? Then you're fried. What happens the day that the maintainer of this library decides that now there is a new version? Then you'll be confused. Have you ever heard the expression, "it works on my computer"? Sometimes it's because you used the brand new version of the library, so it works on your computer, but I'm using an older version, so it doesn't work on my computer. If we download it and have a local version, and you use the local version, I use the local version, because it's a configuration item, it never disappears, and it's always the same version. When you discover the new version, we can decide that we want to test out whether our application works with the new version of the library. If it does, we can download that, and then we have versioning of the libraries. And we can go back to a previous version if you want. Source code, test cases. Source codes and test cases don't really have to be configuration items, because if they disappear, given that we have the requirements, we can sort of recreate them, but it'll be a pain and a lot of work. So usually we want to keep the source code and the test cases. Technical documentation, user manual stuff, if it's important for the product, then it should be a configuration item. What's next for the survival? Well, these configuration items, we have to place them somewhere. And in the standards, they say we have to create a configuration management database. In reality, what happens is that these different types of configuration items, they don't really fit into Git, all of them. And if they fit into Git, then there are some things that we would like to do with them that we cannot do with Git. So the configuration management database, or the repository tool that we have, for the simple things, it could be Git, it could be Perforce. The issues, the tasks, the stories that we have to work on, probably we want to put them into Jira or keep track of them in Excel. So these configuration management database is sort of an ecosystem of different tools that we will sort of have to try to integrate. So how can we do this? So what is a configuration item to a certain degree depends. In this case, we have all the stories, the requirements, the change requests. But once we have identified the configuration items, we want to have sort of this configuration management database. Git is not very useful as a database because apart from the configuration items, we also want to have information about these configuration items, metadata. We want to be able to have attributes, who created this version, and we want to have information about why was this story, why was this feature implemented. So we want to have relations to the change request, and we want to have attributes, so we want to have a real database. And Linus Torvalds never intended Git to be a database tool with attributes and relations. So we will have to try to figure out somehow how we can sort of, from this ecosystem of different tools that are keeping different types of configuration items, how we can actually create a sort of virtual configuration management database out of that. Now that we have the database, we can introduce one more of the traditional configuration activities, the configuration status accounting. One more formal bureaucratic things that these days it's not like it was like 20 or 30 years ago, that once every 2 weeks you deliver a written report to the project manager about the status of the project. These days it's sort of queries into the configuration management database. And all the people, all the developers in the companies can be served by this. So if the project manager wants to know how far are we, hopefully we have a definition of done, or we can know when a change request is closed. And he can say, well, last week we closed 37 change requests, and he get information. If you want to know who implemented this feature, because you have to fix a bug in that feature, and you would like to talk to the person who implemented that, you can make a query on the system, who created this commit that implemented the feature, and you can go and talk to that guy. So configuration status accounting is sort of mining or querying the database, and it's sort of answering frequently asked questions. So questions that are frequently asked, we should have support for making it easy to get the answer. And maybe it's sort of our variant of ChatGPT or Copilot or whatever you're using of these generative AI tools. Success, the next step. Let the work begin. Now we want to turn them into a lean and mean delivery machine. They need to collaborate, they must prove themselves fast and frequently, and they must have a reliable and trustable quality in what they're doing. Now is the time that we should talk about Wayne Babbage. In the early 80s, he was working as a project manager, and he observed what happened in his teams. And he observed certain collaboration problem patterns. And he identified them, he gave them a name, he gave a description, and shared data, double maintenance, and simultaneous update. Simultaneous update, that the changes of one developer overrides and erases the changes of another. Shared data, the problem that your changes impact my changes and disturbs my work. And the double maintenance is that if we have copies, we need to keep these copies synchronized. So when I have configuration control written on 200 different slides, it means that I have to go and change it to change management in 200 different places, and that's not so good. So now that they have to produce code, we need to teach these people how they can collaborate without getting into problems with these shared data and double maintenance and simultaneous update. So we have to teach them something about repository and workspace. If we don't have a repository and workspace set up, then, and work only on a file server, then when you change something, it'll hit me immediately. And if I'm not aware that you have changed something, I might think that the reason why it doesn't work now is because I have changed something. So for some period of time, I would like to work undisturbed from everyone else. I want to have my workspace, and no one can hit me in my workspace. So that's a way of handling the shared data problem. When I'm done, I could say, could I please have the shared data problem, git pull, or perforce get latest, then I will get your changes and your changes from the repository, and I will integrate them into my workspace. But now it means that I'm doing it. I'm deciding when I should be hit by other people's changes. Continuous integration, basically a way of handling the double maintenance problem. You have a workspace, he has a workspace, he has a workspace, he has a workspace, I have a workspace. We have 5, 10 copies of the code floating around. We are changing it in different ways. We have the double maintenance problem. The fact that tools like Git, version control tools like Git, have a merge functionality makes it easy to sort of integrate and keep these different changes and try to keep them in sync. But if you do it continuously, it becomes much easier. So we need to teach them continuous integration is sort of the solution to the double maintenance problem. And the more often we integrate, both download and upload, so you don't make a big task that takes 2 weeks before you upload it, because it means that then even if I try to download the latest changes, I will get a big chunk from you after 2 weeks. Git commands. If we use a version control tool, then the version control tool should take care of a simultaneous update problem. So the tool should say that when you try to do a git push, it'll say, sorry pal, you're not up to date. If I allow this push to go through, and I don't want to know how I can make it go through even if I'm not up to date. At least at the exam. I threaten the students to fail them if they talk about that option in the push. Then the tool will refuse to override. If the latest version that you're up to date with is version 7 and there's a version 9, then putting in version 10, since everyone is using usually the latest version, it means that the changes that are in version 8 and 9, they will sort of, no one will be, they will be gone. And we'll come back to the issue with the return of the zombie bug. You fixed this bug 2 months ago. Now the customer calls in and complains that it reappeared because someone overrode your bug fix. Even if we're using a version control tool, there are ways that we can sort of cheat the tool and sort of create the simultaneous update problem. More success. I want to talk to these guys about quality gates. I talk with my students. We have some Agile projects also at our university, and there I have many occasions to talk about quality gates with my students. The workspace and repository. We are creating work in the workspace. You do a bug fix, you do a feature, he does a bug fix, I do a bug fix, and now we want to integrate them and put them into the repository so we can share them with everyone. Continuous integration, we already talked about that. The next step is to sort of think about, do we really want everything to go into the repository? The first step for my students, for our students at Lund University, is that, obviously, I change something, I want it to go into the repository. When they have lived with that mess for a while, they realize that maybe we need a little more quality. And maybe we could be inspired a little bit by Linus Torvalds. Linus Torvalds doesn't want everything to go into the repository. In the Linux project, you cannot push to the central repository. You can send a pull request, and it will go through the quality gate called Linus Torvalds. And if it passes, it'll go into the repository. If it doesn't pass for any reason, then it'll be rejected and doesn't go in. And we should try to implement a similar thing in these projects. And configuration managers, they are masters of quality gates. We can implement any quality gate you want. If my student says that we want to have something that is slightly better than I change something for it to go in, I say, what about it compiles? And he said, yeah, that's good. And then I implement a quality gate that checks if it compiles. If it compiles, it goes into a repository. Then a week later, they say, could you add that it should also pass all the unit tests? I say, sure. If that's the quality level that you want, then I'll add that. And the week after, it should also pass the acceptance test, and so on. So we can implement the quality gates, but the level of the quality gates will sort of have to be adjusted to what's important for the team. When we have talked to them about quality gates, the next step is to sort of go into continuous delivery pipelines. And I put delivery in quotes here because to me, it's sort of delivering into the repository. That is the first step. We're delivering to the team. And then we could sort of advance it and bring the level of the quality higher and higher such that we feel confident that we could actually deliver it also to the customer. But sometimes it's too painful to build in the quality that will allow us to actually deliver continuously to the end customer. But we would like to have some sort of delivery process to what we deliver to the team into the repository. And a continuous delivery pipeline. if you go and talk to traditional configuration managers, they'll say, that's nothing but an automated configuration audit. Maybe they would like to put a little bit more into the pipeline that Agile people will do, but it's continuous delivery, an automated configuration audit. It was 5 or 6 years ago, I was at a conference in Italy. I was talking about something, I can't remember what it was, and during a break, a young man came to me and said, do you remember me? I said, no. He said, you were here in Parma 10 years ago, and you were telling us about software configuration management, and I remember one slide that you showed us. And any teacher will give his right arm for a slide that students will remember 10 years after. And it was a slide I used when I talked about keeping the repository clean, quality gates leading into the repository, and it was this slide that made a big impression on that student. And the reason why we should have these quality gates, the reason why this young Agile startup must focus on quality is that when shit hits the fan, it goes all over the place. So if we allow something that doesn't work to go into the repository, you will do a pull, you'll do a pull, and you'll do a pull, and now we have this non-working stuff all over the place. And that's painful, and that's a mess. The next task, to outperform our competitors, keep our investors happy, make our customers happy, generate revenue. So now it's real continuous delivery, to be able to deliver to the customers. Maybe also continuous deployment. Actually, in continuous deployment is nothing more than automation of the deployment process. Why should we do this? Well, we would like to have feedback. What do the users like? What does the market like about our things? We want to have revenue. If we can start gaining money on some of the features, the faster we can get the features out, the faster we'll get some money and revenue from it. And automation is king. We should try to automate as much as possible. Computers, they don't get tired. Computers, they don't get sloppy. If we automate a task, then it'll be done exactly the same way every time. So, and if there is a problem, then we know how to debug it and put it right. Branching strategies, well, maybe. I think it comes a little bit later, but if we really want to talk about branching strategies, then a release branch, if we don't have perfect quality in the repository, then we cannot release the latest version, then maybe we want to create a release branch and put the last few things right before we do a release. Later on, when we become more mature, we probably have to maintain old versions of the application that we have sold to people, and then we have to talk about how to handle maintenance branches. The takeaways: configuration control, or the change management, as the first and most important step. If you're not a configuration manager, but if you're working in a project, then try to think about this as a checklist of the things that you should try to go home and see, do we have this? Could we make improvements on the way that we're doing these things? Change management, focus and prioritize on the most important things to work on. Schedule it according to the resources. The important things, the configuration items, and sort of creating a virtual ecosystem or create a configuration management database. Configuration status accounting, try to mine this database of information that we have. Wayne Babbitt's, how to collaborate, how a team can coordinate with as little problem as possible. quality gates, keeping the repository clean, configuration audits, and a continuous delivery. The toughest task I find when I go around and talk to people is that small and medium enterprises, they're convinced that software configuration management is absurdly bureaucratic. It's extremely difficult, and it's very costly, and it slows down development. As you've seen, it's not very bureaucratic. Basically, it's common sense. It's sort of 70 years of accumulated experience with what works and what doesn't work. It's not that difficult. It's not costly. Git doesn't cost anything. Continuous delivery pipeline tunes like Jenkins, they don't cost anything. Sometimes it does slow down development. But I bet that when Lewis Hamilton goes down the straight in his new Ferrari at 350 kilometers per hour, and there's a 90-degree turn at the end of the straight, he would like to have some brakes that can slow down. And sometimes in a development project, we need to slow down. And other times, we can go as fast as possible because we know we have a safety net. So the fact that, or the way that these small and medium enterprises think about software configuration management is an urban myth. So it's not like this. I hope I managed to convince you. If you want to go on with this, then this network of people passionate about software configuration management, we sometimes have conferences and coffee meetings and stuff like that. And if you're more inclined to startups than to software configuration management, then Dave Farley has made an interesting video where he focused much more on the software engineering aspects of startups, what it is that is important for them and where they sometimes fail. Yeah, that was the final slide. I hope I managed to convince you that software configuration management is the most useful thing around.